All right, welcome everyone. Welcome to TheiaCon and in particular also to this talk on building diagram editors with Eclipse Thea. My name is Philipp Langer. I work with EclipseSource, which is an open source technology and service provider, and we are building custom IDEs, domain-specific tools, and modeling environments and those kind of things based on open source technologies, among which is, of course, Eclipse Thea, but also Eclipse GLSP, which is what I will be talking about. So in case you haven't heard about Eclipse GLSP, it's basically a client-server framework that can be used to build diagram editors, such as the ones you see on this slide, UML editors, workflow diagram editors, BPMN editors, you name it, basically all sorts of graphical languages. It builds those editors with modern web technologies in a way that they can then be seamlessly integrated into arbitrary web applications, but also into Electron applications and even tool platforms such as VS Code, Theia, or even the traditional Eclipse RCP. Eclipse GLSP does that by adopting the idea of the language server protocol, which is hugely popular and more or less the de facto standard for building programming language support in modern tool platforms. But of course, GLSP applies this architectural pattern to graphical modeling in order to unlock the same benefits, which is basically enabling the development of browser-based diagram clients, whereas the front end is really focused on rendering and user interaction, and the back end really encapsulates the language smarts. That means in terms of diagram editors, for instance, model management, model manipulation, model validation, and all those kind of things. So those are all encapsulated in a language diagram server and separated from the front end, which is then running in the browser. Eclipse GLSP is an open source framework, as I already mentioned. It's hosted by the Eclipse Foundation and is available on GitHub. So you can find GLSP, the GLSP repository on this URL here. And what this repository or set of repositories provide is basically 4 types of components. That first one is it provides server frameworks that can be used to build specific diagram servers based on it. So for instance, a diagram server for UML class diagrams or whatever language you want to build. Then it defines the protocol. So it's basically a definition of all messages that a client and the server can exchange. Note, however, that this protocol is meant to be extended and extensible. Then it provides a client framework based on which you can actually then implement the rendering and the user interaction based on TypeScript, typical browser technologies like SVG and so on. And last but certainly not least, it provides a set of components that allow you to take diagram editors that you have built with GLSP and integrate them into tool platforms, such as mentioned before, Eclipse Thea, VS Code, or Eclipse RCP. So how does the client-server communication work? Let's have a look at a small example. Let's say you are in a Theia application and you have registered an editor for a certain file type. So whenever a user double-clicks in the File Explorer on a file with a certain file type, then the first thing that will get active is the Theia integration, obviously, because it can register an open handler for this particular file type, which would then cause a diagram editor that has been built with GLSP to be opened. The first step when this diagram editor comes up is to take all the opener options like the URI, maybe the diagram type, and so on. It will send that inside of an initialization message from the client to the server. The server then has the responsibility to obtain, based on this information that it received from the server, from the client, it has the responsibility to load the source model. The source model is really the source of information that you may need in order to produce a diagram. So it can have an arbitrary format. It can be basically anything. It can be an EMF model, Eclipse Modeling Framework. It can be a plain JSON file. It can be an xtext-based file, or it can even talk to external components such as model management servers like EMF Cloud or databases or other REST APIs. Doesn't matter. However you obtain this information is really up to the person who develops the diagram server. You then just have to take this information and produce a so-called graph model out of that information. A graph model is really a structural description of the diagram to be rendered then on the client. So it's basically a typed and attributed graph. So you can think of it of a list of nodes that can be hierarchically structured. Each node has a type, can have additional attributes, and then you have a list of edges, which also can have a type, and they describe how the diagram is structured. This description of the diagram is then sent from the server to the client, which then basically translates that into something that can be shown to the user in a browser. And in particular here we use SVG to really to map that graph model into SVG so that it can really be rendered in the browser. And we use an excellent other Eclipse framework here, and that's Eclipse Sprody. So we use Eclipse Sprody to translate that graph into an SVG. Of course, now you have just a picture and SVG. That's certainly not enough for a diagram editor. So what then comes on top is a set of editing tools on the client, which can essentially react to events on the SVG in terms of keyboard listeners, mouse listeners, and so on. Once there is certain events, react to them and communicate again back to the server what is going to happen based on the events triggered by the editing tool. So for instance, if the user starts moving an element and drops a diagram element somewhere else, then the mouse listener inside of this editing tool for moving elements will eventually create a request for the server to move an element from this coordinate to that coordinate. This will then be sent, of course, to the server where a specific handler will be registered. And this handler would then apply this change, for instance, moving an element, to the original source model, and then basically reapply the same function that we had before in order to translate the source model or the parts of the source model that are relevant back again into a graph model. So that's exactly the same function we used in the initialization phase, and will then send an update model action back to the client so that the client can, again, just like here before in the initialization phase, produce a new SVG and re-render basically what has changed so that the user really sees the effect of the change that they applied. Of course, there is a set of default editing tools like for creating nodes, creating edges, moving elements, resizing elements, and stuff like that. But you can obviously extend also this set of custom tools and also the set of available actions in the protocol with domain-specific ones that you may need for achieving certain domain-specific functionality. Or you can also override certain default tools to adjust their behavior to your needs. So basically, that's the overall theory. So let's have a look at how this actually feels like in practice. Basically, when you create a new diagram editor project, the entry points that you need to implement is basically two things. On the one hand side, you have to create a client module, and on the other side, you have to create a server module. Both of these modules are dependency injection modules, and the idea here really is that you choose a base module that most fits your particular set of technologies. I will talk about that a little bit later. And then extend it with the diagram-specific functionality that you need to provide. So let's start with the server. I will bring up the implementation of a server module. So here in this case, it's a very simple workflow modeling language. That's why it's called a workflow diagram module. And it uses a very simple setup. And the minimal things that you would need to provide in order to be able to render a diagram is basically four things. First of all, you need to specify an ID of this diagram language type. So that's because a GLSP server can support multiple different diagram languages. So you define here when the client requests a certain diagram type, which module needs to be loaded. The second thing you need to provide is a diagram configuration. This diagram configuration essentially specifies three things. First of all, it specifies the types that you are going to use in the graph model. These can be either chosen from the default types coming from the library, from GLSP, or you can also define your own ones. And for each of those types, you can then specify how they should behave on the client. So whether they are, for instance, deletable, movable, resizable, and stuff like that. Next, you need to provide a so-called source model storage. A source model storage is really the implementation of where to load your model from. So that's basically whatever model, a source model you are using, whether it's EMF, JSON, or whatever, you need to provide an implementation to load that into memory so that you can later on process it, modify it, and so on. And then you put that basically into the model state object that is tied to the session of a specific diagram editor. And finally, you need to provide a so-called G-model factory, and that's basically the implementation to transform the relevant parts of the source model into this graph model. So it's a plain unidirectional transformation that you need to implement to come up eventually with a graph model. And with that, this initial phase, and also after each change you may have applied to the source model, this rendering part is basically finished and implemented. Of course, you can then add additional things, which I will show later. You can then write handlers how to react to certain operation requests, implement things like validators, layout engines and stuff like that. But this is basically then optional, and basically the idea is for each additional feature that you need to implement where you need to provide diagram-specific capabilities, you would just override another method and provide a class that implements this particular feature. So now we have the server more or less ready. We can send back the graph model to the client. So now let's have a look at the client implementation. Here on the client, remember we are basically here on the client responsible for now rendering that into an SVG and add editing tools. So basically what we need to do at a minimum is to specify how certain types of the graphical model that we send from the client, from the server to the client, shall be rendered, and we are doing that by adding lines such as this one, where we say specifically for this line that when there is a node of type task automated, then we use this view implementation, or when there is a merge node, then we use that view implementation. And each of those view implementations essentially is just a render method where we get the graph model node as input and we produce SVG as output. And that's basically all that you need to render something. You can then, based on the default editing tools, already achieve quite some behavior. So for instance, when we now open that server and client that we've just seen in code in a browser here in a nice Theia application, and open a file that is registered for this particular diagram type, click it, then we already see there is the diagram that shows up, which basically already does all the steps that we just discussed. In addition, of course, now there is these editing tools that I was mentioning. So you can, for instance, create new nodes. You can start editing certain labels that are specified to be editable. You can create edges. You can then, of course, also apply generic diagram functionalities, like you can mark multiple elements and, for instance, then align them left and stuff like that. You can then also, of course, use undo redo by default. So I'm now clicking Control-Z and Control-Shift-Z to undo and redo certain changes, and so on. So that's basically all the default editing tools. I showed a few of them at least. There is also resize and stuff like that, but you get, I think, the picture. Most importantly, now, since we have full control over all aspects, which is really crucial to implement well-designed diagram editors, we can add also custom stuff on top. So one thing, for instance, that we've seen, the default editing tool allows us to create an edge by first selecting it from the palette and then clicking on an element and clicking on the target element. However, maybe we want to provide a more user-friendly way because we only have one edge type. So you can add additional editing tools that, for instance, react to different events, like when I start dragging from a node here, that I can then when I start dragging from a node here, that I can then directly create an edge, and it would then, for instance, query the server what are the valid targets, and I would highlight them like here with this funky 80s disco animation that I've created with CSS. And then as soon as I click on an element, I would create automatically the edge. Of course, you can then also do arbitrary dynamic stuff in the tasks and the SVG rendering views, where you can even react to zoom events. So for instance, if you want to specify which of who is responsible for this task, you can react to a certain zoom event that when a zoom level has reached, that you start adding arbitrary other SVG, like in this case, an ugly face of someone. When you zoom out, you remove this detail again. If you zoom further out, you can even remove more detail because it's not really readable more anyway. Last but not least, you can, of course, also add UI customizations in the sense that you can add additional HTML on top of a diagram. So that's basically by providing an implementation, which is called a UI extension, that delivers HTML and specifies where to locate this HTML, and then hook up event listeners when the user, for instance, clicks on a certain HTML element, in order to provide domain-specific functionality again. So one example that we've added here is we can activate this UI extension, which shows basically here a slider on the lower left, which is plain HTML. And as soon as I click that, this will then send an action to the server, which is a custom action in this case. The server would then filter down the model to according to certain conditions, would re-render it, and I would recreate the graph model, send it to the client and show it and set it to read only. This can then be, for instance, used to search for a specific set of groups in your model and so on. And now you can see I cannot move this anymore, but I can still, of course, pan and zoom and do all the stuff. And when I click back, I will just go back to the normal editing mode. So this is just an example for being able to add additional HTML-based controls on top of your diagram and then introduce custom actions that do and trigger some custom functionalities. Right. So with that, essentially, we wanted to give you just an overview of what GLSP can do. All of the examples that I showed are open source, so you can have a more detailed look at the source code, of course. So what has been new since the last couple of months in GLSP? And of course, the most important and most exciting news is that even though GLSP has been used in production for quite some time now, there is now, thanks to the excellent work of over 26 committers, there is now the version 1.0 since a couple of months available, which adds tons of features and tons of cool stuff, but I wanted just to highlight a few of them, which is essentially that there is a node-based server framework now in addition to the Java-based server framework that we already had before, which is great, I think, especially if you're coming from, or if you're aiming for a Theia-based deployment, because then you can have a homogeneous development setup where you, on all the different components, use TypeScript, and you don't add an additional runtime requirement because no JVM needs to be installed anymore. And then there has been lots of stabilization in the API, obviously, because there is 1.0, we wanted to provide a stable API. And there has been some server refactorings that now make it basically much more flexible which source model technology you are using, and extract all of the source model specific implementations into ready-to-use reusable modules, so that it makes it much easier to start off to create an EMF-based, JSON-based, or EMF Cloud-based diagram server. And last but certainly not least, there is now a very good documentation, in my opinion, which also provides project templates that you can use to get started quickly for a particular combination of technologies. For instance, I want to use in Theia an EMF modeling backend and a node-based server. And then you choose that particular project template and are good to go. Right. Of course, there's also lots of other stuff that has been added, and I wanted to also mention, since we are at TheiaCon, the platform integration, in particular the one for Theia, and discuss what has been done there. So first of all, the Theia integration for GLSP is really the most advanced platform integration. So this is a very good combination. And this is also not too surprising because diagram editors are often part of custom tools. And this is really where Theia really shines because it provides the most flexibility when you're building when you build a custom tool. So how do tool platforms in general work, including the one for Theia? So basically the idea is that your actual diagram client implementation is completely reusable and independent of the actual platform. But then there is a dedicated platform integration, which does all the platform-specific stuff like registering the editor, platform-specific styling, and so on. And it does that based on the native platform API. And of course, it is extensible, and that's super important because a good user experience in a good tool, of course, doesn't start and end at the borders of a single diagram editor, but you maybe want to integrate into a overall user flow across the diagram and also integrate with other views and components that you may have in your tool. And since that's based on the native platform API, it's therefore really easy to communicate with other stuff in Theia. Of course, the diagram editor is not an island. It maybe needs to communicate with other parts, as I mentioned. Therefore, there are two mechanisms available. So a diagram client, even though it is independent of the platform, can specify interfaces to define what functionality it expects from the platform. And the platform integration themselves can also trigger and intercept GLSP actions to take over certain functionality. And then basically when you create a Theia integration, you can then provide implementations for those expected interfaces and handle certain actions. And only this Theia integration then has direct dependencies on the Theia platform. Well, this still stays independent, and that allows you then to do the same thing for other platforms, for instance. Just to give you a brief overview of how that, which functionality is available for Theia integrations and what you can do, I will just show you a few examples. So let's go back to the diagram editor here. So one thing, of course, is that we are using native context menu here from Theia, and we can really also do native commands that are defined, including keyboard shortcuts and so on. And how this is actually specified, let me just show you that quickly in code. So you see here a command contribution that actually does add those commands that you've just seen in the context menu. And you see this is really native Theia code. So we just register a command contribution and add additional commands for a certain ID with a certain label. The only thing that is then GLSP specific is that GLSP Theia integration provides a dedicated GLSP command handler, which then, instead of doing something arbitrary, it defines a set of actions that needs to be executed when this command is executed. And those actions are then sent into the diagram editor. So for instance, when I right-click, let maybe create another action here. When I right-click here and say navigate to next node, then Theia will bring me to that node. And I can then also, of course, go back, go to previous node, and I jump back. And I can also do that, of course, with the keyboard shortcuts, which work because GLSP will also register context keys that will activate when a certain condition in the GLSP editor is available. So let me just show you that real quick. So when you define key bindings, that's again Theia native. GLSP provides context keys that you can use in expressions when a certain key binding is available. Aside from that, there is many other things that Theia integration provides. So, for instance, you can run validations here, and then the problems view would also show them. So the GLSP populates those over to the problems view and so on. And when you click on them, Theia basically triggers an open command with an additional custom opener argument. And the GLSP editor can then bring you directly to that element because it understands those additional opener commands. Right, there is many other things, like you can process external changes of the files that you are opening. Thea persists also the diagram editor state. So for instance, when I zoom here, maybe I should save, zoom here, close, and then reopen, then Thea will bring you back exactly to the same place. So there's many Thea-specific possibilities already available. But you can add, as I mentioned before, based on Thea native API, your own integrations and additional features. Right. With that, I'm coming to a conclusion. So I think it's really important that for a thing like a diagram editor to have a very extensible platform integration, because of course good user experience doesn't start and end at the diagram editor, but needs to span across the entire tool. And you can do that by providing direct access to a Thea native API that you can then use so that all the different components of your tool can interact and be integrated with each other. But still, of course, it's important to have an architecture that fosters reuse across different platforms so that you can, for instance, also use the same editor than in a plain web application. And I would really invite everyone to get started, because now having API, the 1.0 and the stability of the API available, as well as the documentation and project templates, is, I think, a good time to start. So please try it out, get in contact with us if you have any questions, and I will be happy to provide any more help and support. So just go to eclipse.org/GLSP. You will find there also all the different contact options that are available, like GitHub discussions and so on. And of course, I'm happy to answer any question that you might have. Thank you very much. I see that there is one question coming in from Harman. Is it easy to combine LSP and GLSP to support textual and visual editing of the same domain model? Well, yeah, that's a very good question. Of course, it is not something that is straightforward, but not because of the technologies, whether you use GLSP or any other arbitrary diagram language and or textual language framework. There is obviously some conceptual challenges. So it works very well if you have designed your languages in a way that the graphical part and the textual part are not overlapping, so that you don't need to handle concurrent changes, because sharing like really the command stack is that what makes most of the trouble, because you have to then deal with things like when you change something in the diagram editor, then you need to regenerate parts of your textual editor. And it's very difficult to compute those changes in a way that you maintain the command stack and the white space available in this, or the white space in the text, or even a dirty state in the text editor, and vice versa. So that's something that is conceptually difficult. But as soon as you separate those two, there is definitely very feasible architectural options. There has been a talk that I gave with Miro at the community day about Thea on EclipseCon. I think the videos are online, so please feel free to see if you can find it. Right, I think the time is almost up as far as I can see, at least on my watch. There is one more question that came up. So I would really invite, since we don't have time anymore for this question, just contact us on GitHub, and I'm happy to take on the discussion there. Thank you very much.